Hi everyone. In last class we have discussed about potential and potential difference. Today we are going to discuss about the direction of the current flow. Okay. So potential difference is responsible for a current flow that we have discussed in last class. So in electrical circuit, battery provides the potential difference for the steady flow of the current, continuous current flows in a circuit. Who is responsible for that? Battery. So battery provides the potential difference for the steady flow of current in the circuit. In the circuit means there will be some wire, and through that wire your current will flow. And we have discussed ammeter is used for measuring the current, and voltmeter is used to measure the potential difference and potential. Okay. Ammeter is always connected in series. Ammeter is always connected in series. It is always connected in series with the circuit, and voltmeter is always connected in parallel, okay, across the circuit. So ammeter, this is your suppose ammeter, okay, this is your ammeter. So there will be one positive terminal and one negative terminal. So positive terminal of the ammeter is connected to the positive terminal of the battery, and negative terminal of the ammeter will be connected to the negative terminal of the battery. Okay. So after that we will discuss what is called closed circuit and open circuit. So I will draw a circuit diagram of a electrical circuit. This is positive terminal, this is negative terminal, this is positive terminal, this is negative, this is your key, and this is your any load. Okay, here I have connected a bulb, and negative to negative and positive to positive. This is your ammeter. So this is your key, this is your battery, this is your load, and this is your voltmeter. So voltmeter is connected in parallel and ammeter is connected in series. So what is closed circuit? Closed circuit means this key is closed. That means there is nowhere circuit is broken. Open circuit means key is open. That means no connectivity. So no connectivity. Not only key is open. If any break is there on the circuit, there will be no current flow. Okay. In closed circuit current will flow, and in open circuit there will be no current flow. Okay. So here now suppose this circuit is closed. So this battery is responsible for your maintaining the potential difference in the circuit, so that there will be steady current flow in the circuit. So current flow will be from positive to negative, like this. Okay. So current flow will be from positive to negative. We know for current flow electrons are responsible. They are the charge carriers which moves so that current will flow. And we know electrons are negatively charged. This is negatively charged. Okay. So this is your negative terminal, this is your positive terminal. That means your electron will flow from negative terminal to positive terminal. But now observe, current is flowing just opposite to your electron flow, from positive to negative. So it is just opposite to your flow of direction of electrons. Why? Why current flows from positive terminal to negative terminal? Let us discuss. So first point I want to mention why we are considering the conventional current flow from positive to negative. Actually, in 18th century, Franklin gives the concept of current flow. Okay. That time when he has given that concept of current flow, that time concept of electrons and atomic structure were not known. So, after that time, after Franklin has given this current flow direction, actually what he has done, he assumed that the accumulation of charge as positive and the vacant charge are negative. So he has assumed that thing, that accumulation of charge will be positive and the vacant charges are negative. So it was assumed that charge is flowing from positive to negative. But later on in 19th century, J.J. Thomson, he has discovered the charge of electron. Okay. So that then everybody got surprised. So that is the, you can say, a path-breaking discovery. So to avoid the confusion, they kept the direction of current like that, it will go from positive to negative and let electrons flow from negative to positive. So in all the books, we will read like electron flow from negative to positive, and it is just opposite. Current flow is just opposite to the flow of electrons. Okay. So this is one theory which is supporting to the concept of current flow from positive terminal to the negative terminal. And there is another way to look at it also. Suppose you know in electric copper wire, suppose current is flowing, and this copper wire, this I have just zoomed in. So copper wire means there will be lot of atoms. Okay, lot of atoms will be there in the copper wire. Let this copper wire, before connecting this copper wire to any terminal, this battery, so there will be atoms. So atoms will be there and electrons will be here. So all these electrons, free electrons, will be roaming freely, randomly rather, in all the directions. So when we connect this copper wire to a battery, suppose this copper wire is connected to the positive terminal over here and negative terminal over here. That means we are giving the force to the electrons to move in a particular directions. So what will happen? So when, suppose, now we have connected the copper wire to the positive terminal and the that means to the battery. So let the battery's positive terminal over here and negative terminal. Now see. So there will be this copper atoms. A lot of copper atoms. So for the explanation purpose, I am making like this. Okay. And you know the outermost electrons are responsible for the current flow. So when we are supplying this potential difference, that means we are providing one electric force, so that that energy will knock out these electrons and it will become free. So it will knock out from the valence electron cell and it will become free, and it can move freely and it will flow. So since this is your positive terminal, suppose we have given now, it is connected to the terminal, so we have given the energy, we have given that force. Actually that force is called electromotive force, EMF. So now this electron got the extra energy, so it will now become free and it will move. So where it will move? Since it is positive terminal, this electron terminal are negative, electrons are negatively charged. So this electron will now move towards the positive terminal. So what will happen? This become vacant. So now this electron will move to this place, and to fill up this electron place, now this electron will come and take this place. So what you are observing? You are observing your electrons are flowing like this from negative to positive. Actually what is happening, when electrons are going from this atom, so this atom becomes positively charged since electrons is lost from this atom. Okay, and now when electron is going from this atom, this positive charge and this one became, now first this atom became positive, now this one become positive, now this one become positive since this electron is going from this place to this place. So you just observe this positive charge is not moving. Actually this is the relative shifting of positive charge from positive terminal to negative terminal. In all the books you will see the current flow, positive charges are not moving. These electrons, negative charges are responsible for the current flow. This is true. This is the fact. But in all the books you will see there will be a line कि conventional current flow is because positive charge is flowing from this to this. So conventional flow of direction is from positive to negative. So now I think I am clear on this. Electrons are moving from negative terminal to positive terminal. Positive charge, this positive charge is shifting actually. It is a relative shifting. If you see from outside, you can observe that positive charge is shifting. So this is really relative shifting of positive charges. But actually electrons are flowing, those who are negatively charged. So in all the books you will get electrons are flowing from negative terminal to positive terminal and current is flowing from positive terminal to negative terminal. So to avoid all the confusion, when Franklin gave one theory, then Thomson has discovered about electronegative charge. So there confusion arises. From which direction to which direction we will write for the current flow. Okay. So to avoid all the confusion, they kept the direction of current like before. It will be from positive to negative. Okay. Actually, it makes no difference in which way current is flowing. How? So finally, they have decided to keep the direction of the current flow from positive to negative. Actually, it is making no sense. If current is flowing from negative to positive terminal, positive to negative terminal, the direction of the current flow doesn't matter. Why? Current, you know, current is a scalar quantity. But you will be telling why current is a scalar quantity? Because current has magnitude. It has got its magnitude. Current has magnitude. And it has got its direction also. Current is flowing from this direction to this direction. Then how come current is a scalar quantity? Current is a scalar quantity. Actually, you can say current is a tensor. Current is a tensor of rank 0. That is not under your 10th syllabus. Current is a tensor of rank 0. So rank 0 means it is scalar finally. So how to visualize the current is scalar? Suppose this is a junction, like a connection where wires are going like this, you can say. So this is junction. Suppose 2 ampere of current is flowing to this junction from this direction, and from this direction suppose 3 ampere current is flowing. And now another wire is like this connected to this junction, Now 5 ampere current will be flowing from this junction to this. So 2 plus 3, we are not doing the subtraction because directions are different. We are just adding up the currents. So current values are just you have to add up. So that's why it is scalar. We are not adding currents like in vector way. This junction, the rule is the amount of current entering into the junction will be equal to the amount of current leaving the junction. So the amount of current entering the junction will be equal to amount of current leaving the junction. So it is a scalar. So current is a scalar. Hope I am clear about the direction of the current flow. In next lecture I will discuss Ohm's law and what are the limitation of Ohm's law. Thank you for watching.